Look at this picture. What you're seeing is a cosmic object very far away, shining bright in the early universe. But finding this bright object has solved a mystery that puzzled astronomers for years. Because scientists believe the universe began about 14 billion years ago. Right after the Big Bang, the universe entered a long, dark period called the Dark Ages. During this time, thick clouds of gas covered the whole universe. Even the strongest telescope ever built couldn't see past these dark clouds. But for many years, scientists kept noticing strange flickers of light coming from somewhere inside them. This strange discovery has stirred up debate among astronomers. Not long ago, the Webb Telescope spotted two ancient galaxies for the very first time. Strangely, these galaxies don't look like anything we've seen before, and that has scientists asking big questions about where they really came from. These findings from the Webb Telescope have raised even bigger questions. Could we have the age of the universe wrong? Or maybe we misunderstand where these galaxies came from. So what exactly is this mysterious light, and where is it coming from? Thanks to new data from the Webb Telescope, we may finally have an answer, and it means some of what we thought we knew about the early universe might need a second look. The new images show that this light actually comes from something called Lyman-alpha emission, a special kind of glow given off by hydrogen gas. These images also reveal that many more galaxies were colliding and merging in the early universe than scientists ever realized before Webb came along. Those mergers sparked huge bursts of star formation, and that's what created the Lyman-alpha glow we're now seeing. Scientists always thought this light should have been blocked. Thick clouds of hydrogen gas filled the space between galaxies during the Dark Ages, and by all accounts, that light should never have reached us at all. But somehow, we're still seeing it. Researchers recently found the answer. As stars formed and gathered mass inside these early galaxies, two things happened at once. The stars gave off Lyman-alpha light, and they also carved out bubbles and pathways through the thick, neutral hydrogen gas that normally blocks light. These bubbles and pathways let the Lyman-alpha light slip through, which means the light was able to travel far enough for us to detect it, even from beyond the Dark Ages. In a separate deep field image, scientists spotted two more galaxies sitting beyond the darkness of the early universe. Scientists say these galaxies don't match anything we've seen before. What's more, both galaxies show an extremely high redshift, and astronomers say that if these really are galaxies, it creates a serious problem for our current theories. This chart gives us a clear picture of the farthest galaxies ever confirmed, all thanks to the Webb Telescope. It shows the most distant galaxies we've measured using precise spectroscopic data. One of them, called GNZ11, sits about 13.2 billion light-years away and was actually first spotted by the Hubble telescope. A new picture from the Webb Telescope has uncovered something amazing inside this galaxy. Astronomers found a supermassive black hole sitting right at its center. This makes it the most distant black hole ever recorded, one that formed just 400 million years after the Big Bang. That timing is a huge problem because a black hole this size shouldn't even be possible yet. Scientists say the black hole's size just doesn't match up with how young the universe was at that point. Neither dying stars nor merging black holes in the early universe could produce something this massive so fast. That means we might need a brand new explanation for how these giant black holes formed so early on. But that's not all. There's something else in this data that has left astronomers around the world stunned. Take a look. These are the most distant galaxies the Webb Telescope has ever found, and the red markers show galaxies that have already been confirmed using spectroscopic data. Right now, the record for the most distant confirmed galaxy belongs to one called Jade's GSZ 13-0, sitting about 13.47 billion light-years away. But there's even more to this story. Here we can see two more galaxies, both at a redshift of around 16. That means both of them existed even before the Dark Ages ended. This is shocking, because our standard models of the universe say galaxies shouldn't have formed until after the Dark Ages were over. Yet here they are, massive, strange galaxies that somehow existed before that point. This discovery suggests galaxies formed much earlier than our theories ever predicted. Now scientists are left with a tough question. How do we explain galaxies like these? One possibility is that the universe is actually older than we think. Another is that something unusual happened right after the Big Bang, something that sped up galaxy formation far faster than expected. So far, no one has confirmed these galaxies through spectroscopic observation. But if that confirmation comes through and their redshifts check out, it could shake the very foundation of modern cosmology. There's one more idea gaining traction among scientists, a theory called conformal cyclic cosmology. This model suggests our universe might not be the only one. It might be part of an endless cycle. Nobel Prize-winning physicist Dr. Roger Penrose argues that a universe existed before ours, which he calls the previous eon.
This, on the left, is the sort of standard view of what the universe looks like, Big Bang out to this exponential remote future expansion. This is stretched and squashed, but this stretched out infinity becomes the Big Bang of the next eon. I'm calling that an eon, A-E-O-N, and we had a previous eon, another one after us, and rather than the Big Bang to infinity being a unique event and that's it, I'm saying this is something which continues. There was one before, there was one after, and you might say this is a totally outrageous idea, but I did say that there is good evidence for it, and I gave you this probability of 125 to 1. Let's say there's 125 to 1 that this is the correct picture. Well, that's a little bit outrageous. I'm not sure I quite say it like that, but it is at least some good evidence that it might be true. At least some of the implications of the theory could seem to be true.
According to his theory, black holes from that earlier universe slowly evaporated away, just as Stephen Hawking predicted. And the energy released from that evaporation may have sparked the Big Bang that created our own universe. Penrose also suggests that leftover energy from those long-dead black holes could have sped up the expansion of our universe in its earliest moments. Scientists think these dead black holes from a previous universe might explain why we're seeing supermassive black holes and giant galaxies so early in cosmic history. Honestly, everything the Webb telescope has found so far challenges what we thought we knew about the universe. And it's no surprise, because in just its first 3 years of operation, JWST has already broken record after record. The most distant galaxy ever seen, the most distant cluster of galaxies still forming, the most distant black hole, the most distant red supergiant star, the most distant gravitational lens, and the most distant quasar. These discoveries open up a wild possibility. Maybe our universe is much older than we originally thought. Or maybe it's just one link in a long chain of connected universes. Or maybe it never actually had a beginning at all. When you consider that our universe already seems infinite in size, the idea that it could be infinite in age too doesn't seem so far-fetched. Under this way of thinking, the Big Bang wasn't really the beginning of everything. It might just be one moment, one point, in an endless, ongoing process that has always been happening. Alright, that wraps things up for today. If you made it to the end of this video, drop a comment and let us know what you think about these discoveries, and what you think the real age of our universe might be.